going to get into the creative grading portion of this. And Klaus Weber has been working on this paper for quite some time, presented some other things to us in the past, so he's very familiar to a lot of you. So Klaus, we're just going to get right into it and let you start. So come on up.
Okay. So, yeah, also welcome from my side, and I'm happy that I see still quite a few people in the room. So since the last 2 days I was thinking what to do, how to start and kick off the presentation here and keep you somehow awake. So to be the last one of the day is of course a challenge, but since we all like challenges in our business, so let's take the challenge. And I hope at the end of the presentation you think it was worthwhile to spend 30 minutes or so with us. So yeah, the name of our presentation is Creative Grading, or Why a New Way of Broadcast Camera Control is Required or Needed. And that's quite in contrast to the presentation we have seen just with an automatic look adaptation. It's the opposite actually. How to make it easier for an operator to keep a certain look during a production. So I have prepared the following agenda. So I give you a quick background about live camera shading, and live means any type of camera control during a live event, typically like an OB event production or a studio production for live applications. And then how to migrate from what we call camera shading today to something which is more likely similar to what grading means today. And that means how to change from a purely technical to a more artistical image control. Because today we use typically a kind of signal-based workflow for the image control, and that has to change to a more look-based solution. And give you a quick update about how the new formats and the new requirements in the market has an influence to the way of camera control, and also how the human interface need to change to cope with that one, and then one slide for conclusion. So that's the high-level overview of the presentation. And let's start with the background of live camera shading. So first of all, the main difference between a live production camera, a typical studio camera or an EFP camera, compared to any other camera, if it's a camcorder or a digital cinematography camera, is that in a live camera, the picture needs to be permanently controlled all the time. And you have an image control operator that's called the camera shader, which is permanently working on the camera. So, and one of the specific things at live production is that the image need to be perfect at any time. Since there is no post-production, there is no way to fix an error. If there is an error or is something not optimized, it will be visible for anybody watching the content. And that's quite different to any other type of applications, if it's a camcorder shoot or a digital cinematography production or whatever. And it's also so that typically a live production is a multi-camera production. So you have different cameras shooting different angles, having different conditions, and they all need to be as good as possible to the given situations. And maybe even more important, if you have a multi-camera shot, that all the cameras used for the shoot should look identical. Identical in a way that they look as close as possible so that you can switch from one camera to any of the other cameras at any time without distract the viewer. And that's quite a challenge for a camera shader, since in multi-camera productions you also have maybe multiple camera shaders working at the same time on a number of cameras. And one of the interesting things, if you look a little bit back, is that the tools which are available, which are used to do camera shading, have not been changed for many, many years. If you also go back 30, 40, 50 years from now, and you look on a camera control panel from that time compared to today, there is a lot of things still similar. So here we see on one picture camera shaders on their work. That must be in the 60s, I guess. That was black and white camera systems actually image Orticon cameras. That was one of the oldest pictures I could find, showing somehow operators in their work. And live camera shading is done by people which are called in different languages, always somehow related to engineering. Like in German, a camera shader is called Bildtechniker or Bildingenieur, or if you translate that one-to-one into English, it's image technician or image engineer. Same in French. French, I don't know French, how to spell French, ingénieur vision or something. It's vision engineer, same thing again. So we always have the name engineer or technician connected to a camera shader. One of the main reasons is, in the early days when camera shading was used, it was mainly to remove technical imperfections. The cameras in the old days had a lot of temperature drifts. They had aging artifacts. It was purely analog devices with a lot of changes over the day. And it goes to extremes such as some of the earlier tube cameras. When you turn them around by 90 degrees, already the Earth's magnetic field had an impact to the image. So it needed to be permanently controlled, and it was more a kind of fight to keep the camera in the best technical conditions rather than having any time to spend for applying a look. And the second role from a camera shader from the beginning was to adapt the camera best to given conditions. I mean, the conditions are not always ideal, and especially for outside productions, conditions are not under control, though that is an additional role for a camera shader. And today, maybe it's even much, much more important than the technical imperfections. If you look for the latest generation of fully digital CMOS cameras, there is hardly any temperature drift, any aging artifact, and whatsoever. On the other hand, we have already for many years, especially from the film post-production side, something which is called grading. And grading is done by a colorist. A colorist is not called color technician or color engineer. It's much more an artistical role rather than a technical role. So he do fine adjust, saturation and color balance. He convert possibly raw material during post-production into a usable material, or let's say a viewable material. And very important, he add a look. And the look as it is requested to fulfill the requirements from production or whoever is involved in defining the look. So that's quite a different role compared to camera shading. But if you look today, we have changes also in the way how live productions are done. So, and going back to the camera shading today still is very much a signal-based workflow, I would say. So a camera has a certain kind of, you call it a kind of block diagram, how the control is done. You have an imager, or no, you have a lens, then you have some optical filtering, then you have images, then you have a preamplifier, and all the different steps. Even so, most of the processing is done in a digital processor. It's still function by functions adding in a certain flow. And that's the way how camera control is done. I have one graphic for that in the following. On the other hand, look-based camera control solutions, more the grading thing, it's completely different because you define a look and you want to keep that look during the production. And it has to be the same for all the cameras during the whole production. And the look is not defined typically by the camera shader. It's not the vision engineer who decide what the look of the production is. It's different people. It's typically the lighting director. We have seen in the last years that more and more lighting directors are kind of forcing the camera shaders to keep a certain look. But there is already a challenge that they use different languages. I mean, a lighting director often use things like, give me a more punchy look. But on no camera control panel in the world, you find a knob called punchy look. So it means, what happens? The camera shader needs to translate that word into a function. If he is good, he knows pretty well how to achieve that punchy look. But that's something, it's really hard to learn. And we have a generation of camera shaders coming up which grown with applications like Photoshop. They can make a day shot into a night shot or the other way around. They are really, really good in creative things, but they don't necessarily know the workflow of a camera in detail. So, but there might be other people involved in the look, set designers, producers, marketing people, or sometimes even the customer itself. So if a production is done for a certain customer, he has a certain idea how the look should be, and he tells the production what he wants them to achieve. And this is a real challenge, how to do that best. So once again, the signal-based workflow is based on kind of block diagram inside a camera, function by function. So on the other hand, here just an example of a picture. That's a real shot from a production we done earlier this year on an HDR shot in St. Paul, Minneapolis for Red Bull. So you see there is a mix of different light sources. There is really bluish light, there is yellowish light, almost reddish light on the racetrack. So from a technical point of view, there is no way to make a perfect picture here. I mean, as an engineer, you would need to say, well, that's the wrong lighting. I cannot achieve a good picture. But that's not what the production want to hear. They want to have a certain look. And I think this blue light was chosen not as an accident. That was wanted, and they wanted to have this kind of look. So in the early days, when we had a typical live production, like a music show or production or whatever, lighting was set in a way that it is optimized for camera shooting. That's not what is done anymore today. Today, the camera needs to generate the look which is wanted based on the given conditions. That's quite different. So as I said, for an experienced camera shader, it might be possible to achieve the look what is requested by adding a certain amount of controls. But even if he can, it might not necessarily be the best way to do and the most efficient way to do. There must be better ways to do. And if you have a non-experienced camera shader, he might not achieve the goal at all, whatever he do. So, and if you go to a more artistical camera control, you need different workflows, you need different tools. Just one example. We have already in some of our latest cameras controls which combine certain settings. Like we have something which is called mid-tone control. Mid-tone control combines gamma, gamma curve, black stretch, black press, and certain functions into one control. Unfortunately, that control has not been foreseen when the control panel was designed, so there is not a direct access to the knob. That's the first problem. And the second is, even if you have that control, it does a lot of things in the background which is not necessarily understood well by the operator. So it means you need to make it sure that somebody want to use that control, understand what it does. And as I said, the main problem is that it's kind of hidden in the menu, and you have to bring that up to the front. So, but in addition, what we see more and more that we have completely new requirements. We have new formats. High dynamic range is one we have heard multiple times, also during the day. High dynamic range has a certain amount of controls and settings, which again have not been foreseen when the current generation of camera control panels was designed. We have wide color gamut, 4K, IP, which have certain requirements for the settings. And maybe more difficult even, we have simultaneous productions more and more today, HDR, SDR, 4K, UHD, and HD at the same time, and so on. So it means how to control these functions if they are not available on the control panel in direct access. So, and since these new functions have not been accounted when the control panels was designed, it's very hard to control. Of course, you can always delegate a function to an existing knob, but then the question is, what happens to the function which was on the existing knob? How to control that one, and how to make that visible. So, something else needs to be done. So, and for the today's requirements and the future requirements, we have to do something to have a better way to control images. So what we did in the last years, we did a lot of studies with some key customers around the world, and to better understand what are their challenges in live productions. where they are facing problems, limitations. It started with some drawings on paper, and some of the drawings have been translated into 3D models, of course non-functional printouts, just to play with the knobs a little bit and the size of the panel. And what we have realized relatively early on, that to go purely to the colorist, let's say, setup, have a big, large panel which control multiple cameras on one panel after selection, that's not what is required for live. For live, people still want to have a direct access for all the cameras they need to control. So it means we have to have one control panel per camera. That's something we learned pretty quickly. On the other hand, so this automatically somehow limits the size of the panel, because if you want to have 20 cameras to control in an OB-WAN, you cannot have 20 times this width. It has to be a certain size, so means the size which we have today is more or less given already. But nevertheless, there was requirements to make the system more flexible, more adaptable. So, and what we have found is that some functions need to be in permanent direct access. They need to be accessible, we call them blind. So means the operator needs to know without looking, if I touch to that position, I have that function. So functions include, of course, the iris, the master black, but also white and black gains and balance, that they need to be in direct access. But in addition, when we asked the people, what additional functions do you want? How many there are? Typically say, I need only 2 additional functions. And you ask which one? The customer said, I need clean scan and saturation. Okay, fine, 2 extra knobs. Fine, we are done. Then you ask the next one, he said, I need 2 or 3. Which one? I want to have skin contour, detail level, and whatever. So it means it was always only 2, 3, maybe 4 functions they want to have, but everybody had different functions to select. So it means in no way you can add enough direct knobs to have all the different requirements in one panel. So it means the compromise we have found, the best compromise is very likely to have an area of the control panel where you have really fixed, frozen settings, which is not changeable, plus you have a section where you have additional controls, which any function you can think of can be allocated to. One of the challenges is if you have functions which are allocated to a certain position, knob or control, you need to make sure that they are clearly visible, which function is on that. So it means you need, in addition to these controls, a relatively, let's say, large, bright display which can show which function is allocated and what is the setting of this function. So it means the combination of fixed controls plus fully variable controls, which can be easily memorized, recalled as production setups and so on, are very likely a very, very good compromise. But in addition, there is a problem. If you have now so many functions to be controlled and you want to control so many things at the same time, you need to make sure that the functions are easily visible. So means in addition to just having a display which shows the settings of the different functions like RGB gain, R50, 55, and 45, you need to make sure that the people easily understand what 50, 45, and 55 or whatever it is means. And we believe a graphical display translating these numbers into functions and into visible information is very important. So we are working on screens which translate, for example, the whole black to white contrast range into a graphical display, such as a kind of gamma curve or whatever EOTF or actually OETF has been selected. So on one graphical view, you can see what you are doing. So with that, you can also very easily compare cameras, not by numbers, but by graphical displays. You can use one as your reference camera, and you can look what the difference from your reference camera is to your one, just looking on the graphics. And of course, there will not be one graphic required. You will need one for the light information, one maybe for the contrast, maybe one for color, one for the image enhancements. So multiple screens need to be available, which you can select depending on which function you want to compare. So the advantage of these graphical displays is that the camera shader needs less technical knowledge to understand what he's doing. And it's also a very great way, we call it to learn on the job. So it means if you have non-experienced people working on that camera, they can learn very easily by looking to the graphic and see whenever they touch a control or a function, how that interact to the graphical representation. So as a conclusion, so the way broadcast cameras are controlled today is actually based on the way they have been controlled in the early days of television. And if I say early days, that really goes back more than 50 years from today. But with many new features and functions and formats which need to be controlled and the new workflows which are required, new tools will be required to achieve the best possible results in the most easiest way. And we believe an easy to configure control panel combined with an extensive, intuitive graphical representation of the controls in logical groups together is a future-proof solution, and it can be upgraded by software updates easily, whatever requirements will be added on. And we believe it's time for a change, going from the workflow-based control solution much more into the look-based solutions, and it's time for a change from broadcast camera control from the traditional way into the future. And thank you for spending the last 25 minutes with me and being awake still, and I'm more than happy to answer questions, and I already wish you now a great evening. I hope most of you have the chance to go to the party tonight. I will not, sorry for that, but again, thank you for listening.
Hello, thank you very much for the presentation. Just a question about the future of camera control. I have a lot of stick time behind the OCPs of pretty much every camera manufacturer. And my question is this. When you're in a mobile unit or in a live television studio, real estate is very, very expensive and prime. So while the need for additional functionality and a rethink of how stuff done is a clear concern, what do you envision in terms of kind of maintaining the footprint that those video engineers or vision engineers have right now?
Okay, I'm not 100% sure if I understand the question. I think your question is footprint means the size of the solution.
If I have 10 cameras, I have 10 operational control units in front of me. And if we're not talking about a different way of thinking about how to control each of those, similar to what looked like a Dolby Vision control center in post-production, good. How exactly, what do you envision the way to achieve that?
Yeah, let's say from our findings, based on the workshops we did with customers and so on, we was told not to change fundamentally the footprint as it is today. And the reason is, if you look in typically OB-Van productions is the biggest challenge. I mean, in studio buildings, you often have enough space to move people more far away from each other, but in OB-Vans is the most severe thing. But that's also the way or the place where most of the cameras are used. The 20 camera productions, the 30 camera productions are typically OB-Van productions. So it means you have a camera operator or camera shader, which controls in Europe more likely 3 to 4 cameras. In the US, it's more 6 to 8 maximum. So it means you can calculate how much is the width of a person and how much width you have for your 4 to 6 OCPs. So you cannot go below a certain, beyond a certain size, otherwise also your table gets too wide. So it means if you look today, nearly all OCPs on the market have the same width or plus minus half a centimeter in width, and that's for good reasons.
That's not a, that's
and we are not going to change that one. So it means the next generation of control panels will have the same physical size as the previous one, and as I said, for good reasons.
Thank you.
It's Bill Feitner with Colorfront. Hopefully it'll behave. Yeah, good presentation. You certainly stressed the point that we're still in the dinosaur age of camera control and everything. So one thing, moving toward more of a look-based effort in terms of video control or shading, have you taken that into account in your proposals as far as who's going to design the look? If you design the look on one camera with a set of controls, that you can have some global or methodology of publishing this across the rest of the control panels. And then my second question is it was interesting seeing the graphics and everything, and even a description of what some of the knobs would do, but most of those are dealing with conventional broadcast 709 SDR type parameters, and we're entering a world where we're not just delivering one flavor, we're delivering simultaneously, at least for quite a while, some form of lower dynamic ranges and then higher dynamic ranges. And I put plurals in those because that's really where we are. And I think we really need to rethink the knob functionality as something that also can globally deal with both. I mean, we are not going to have two different trucks and two different sets of people making two different grades. So one side, you know, we need this concept of what we've always been working on, especially on the non-real-time front of a common master and a way of dealing with parameters that address both HDR and SDR ranges and cutting between the two, and they match. So. And I also think the control interfaces and the controls, as well as the scales and the graphs, will need to drastically change away from our standard video style if we're going to address these wider ranges. So anyway, those are my comments. I don't know what your thoughts are on that.
Yeah. The thing is, so first of all, we need a tool to have the capability to do that, to control different, let's say, signals at the same time. With today's panels, we cannot.
Yeah.
I mean, you have a certain amount of knobs, you have a certain amount of controls,
yeah.
And in some cases you can toggle between two settings, but it's very hard to handle that at the same time. And with the new concept we are working on, you have now the possibilities at first time to have on a graphical display, you can easily see two curves at the same time. And you can control them in parallel, you can lock them, you can separate them, you can add change a certain offset to it. That's all possible because you have this new tool set. With the current system, you cannot.
We might need an octopus instead of a colorist to deal with all of those things. So, I mean, one of the proposals I would put forward is that we come up with the set of, and this has already been done. I think it's been proven and done well, that we have a set of parameters and controls that adjust the look of the picture and what you're trying to do. It could make, for example, a more punchy picture, but that's relevant equally if you make it more punchy, the SDR output and HDR. In other words, we're working with this common master. Later, we're putting out the SDR and HDR, and we're relevant to both because there's not time to deal with two different outputs and addressing each one separately. So.
Yeah. The way how to handle this multi-standard productions also depends heavily on your workflow. So we have our, of course, own concepts about HDR, SDR compatible workflows, which does not need too much parallel control. So it is based on the idea that you produce your best, highest HDR layer, and you derive your SDR by a down mapping. We have all the tools. We have static down mappers, dynamic down mappers, at least in the labs and so on. And but again, the new control concept help us to have higher flexibility and better control.
We've had a lot of practical experience in broadcast trucks in several cases doing just that and having a set of controls that affect both equally, and the video controller is quite happy if he makes an adjustment in one that it's carrying through to the other. And so I think we really need to move to that, or we're never going to get through it. And so it gets back to whether you call your common master HDR, SDR, I just call it the common master, and then we put them both out. So.
Okay, thank you. One thing I have to say, I forgot to mention, my name is written here, but the paper was not written by myself alone. I had some contributors from the factory, and Ronnie van Geel, our head of product management, was a co-writer, the co-author of the paper, and I should not forget to mention his input. And once again, thank you very much for coming and listening, and have a good day.
Thank you for watching. If you enjoyed this video, please tap the like button and also subscribe to our channel to receive notifications when we add new content. For more information about us, please visit SMPTE.org. We'll see you next time.